It is a good question, but we did it already. Question 4. We did these questions already, but in degrees. Now we're going to redo them in radians. In fact, one of the things that makes chapter 6 a little bit challenging is every single thing you've ever done in trigonometry is now available as a grade 12 question, but the only thing that I do is change degrees to radians. So you have to re-know all of your trigonometry, but now it's just in radians instead of degrees, which isn't really that hard because all you basically have to do is go to your calculator and do that little change to radians. So look at this question. -4,3 is a terminal point of angle theta. We did this before. What did we do? We drew 1, 2, 3, 4, 1, 2, 3. I have that point. -4,3 is right there. I draw a triangle back to the nearest x-axis so that I have a reference angle. Once I have that reference angle, I already know this length is 4 and this length is 3. One of my favorite right angle triangles because all the numbers are nice. 3, 4, 5. Pythagorean triplet. Perfect. Okay? Now we have to find out what theta is from -2 pi to 2 pi. So this part right here is saying you have to do your work in radians instead of degrees. -2 pi to 2 pi is like once around in the positive direction would be 0 to 2 pi. Once around in the negative direction would be 0 to -2 pi. So first of all, we need to find our reference angle. And finding a reference angle, in this case, you could use sine, cos, or tan. So if I did tan of my reference angle, opposite is 3. Adjacent is 4. I go to my calculator, it's in radians already, so I can go second tan inverse 3 divided by 4, just the same as you would in degrees, except you get an answer that you're like not as comfortable with. 0.643. About, what do you think, 36 degrees? 35 degrees?
This times 28.
Well, this is 0.6 of 1 radian. 1 radian was a little bit less than 60. So if I did 60 times 0.6, 36.87. Okay. But we're just going to write 0.6435. Dot, dot, dot. In degrees, if you wanted to find this blue angle in the standard position, and it was 36 degrees, what would you do? You would do 180 degrees minus 36 degrees. But now we're thinking in radians. How far is it halfway around? That's pi minus your reference angle. And so that angle theta is going to be pi minus this answer. 2.498. What does it want me to round to? To the nearest tenth. 2.5. Then this angle in the negative direction. Well, if it was in degrees, do you see that you would do 180 degrees plus your reference angle? And then whatever answer you get, just make it negative because it's going in the opposite direction. I'm going to do the same thing here. I'm going to take pi and plus my reference angle, 3.8, and make it negative because I'm going in the negative direction. Same idea as degrees. just hurts our brain a little bit more because we're not used to it. Also, we get answers that we're not quite as used to as well, right? If you think of a circle, does this look like 1, 2.5 radiuses to get there? Maybe, maybe not. Okay, part B. Sorry, Willie. Here we go. Part B. Sorry, Amber. I'll have to try to aim so that the shrapnel goes to the side.
Shrapnel.
It's Brett.
Just aim for one angle going like that.
Oh, but still. Okay, part B. We're given that cotangent is -2. The first thing I'm going to do is take tangent and write the reciprocal. If cotangent is -2/1, then tangent of theta would be -1/2. I'm going to think about my cast rule. Cast rule says where things are positive, tan is negative, so I know it's either here in quadrant 2 or quadrant 4. So if I like, I can draw a little picture. I know there's an angle in quadrant 2. I know there's an angle in quadrant 4. With both of those, I can go back to my nearest x-axis and label my reference angle. Then if tan of theta is -1/2, then tan of my reference angle would be +1/2, and tan is the opposite side over the adjacent. So I could label those. In fact, if I did a squared plus b squared equals c squared, I could label my hypotenuse as well, the square root of 5. And from that, we can now find our reference angle, because the question is asking for, to the nearest tenth of radian, we want to solve theta. Again, it's in radians because it tells us from -2 pi to 2 pi. So that means positive angles from 0 to 2 pi and negative angles from 0 to -2 pi. So I always think about solving for my positive angles and negative angles separately. In my picture, these are my positive angles. This one in standard position and this one in standard position. For my negative angles, I would have this one in standard position and that one in standard position. So I need to find all 4 I was checking to see after 3 times, would sound be enough? But not quite. We still need the impact of the water pellets. Okay. So from here, what we're going to do is we're going to find that reference angle. Right? Reference angle, we know that tan is 1/2. Everything is positive with a reference angle. And, oh my goodness. This is when you know you've done too much math. I'm going to guess what my calculator, is this what the number is? If it is in radian, oh my goodness. That is useless. Why is that in my head? I want to open that up so that I can remember. What's your name? I'm just kidding. Sometimes I forget names. Why do I remember things like this? I haven't forgotten your name. But why is that stuck in my head? Okay. There's our reference angle. So now we can find our blue angles. And I'll show them on here. Does it make sense that this one is going to be pi all the way around minus your reference angle. So one of the things I'm going to show you in your calculator that's kind of nice, because we're going to use our reference angle a lot. Above the on button is a store button. I can store it as x, and then I can go pi minus x, 2.7. Does it ask me to round to the nearest tenth?
Yeah.
Good. This one here, I'm going to go all the way around 2 pi and minus my reference angle. And I'll do this one, and you can do the other two on your own, but this is why it's nice that I have it stored as x, 5.8. And you can do the red ones as well. One red one is going to be negative 0.5, and the other one we'd have to figure out. Questions? If you do want to write them down, are 13 and 14.
Oh.